So let's take a look at this probability here. What's the probability of being dealt a jack and a red card? Now, first class, this probably seems pretty similar to the last one we did, where it was a jack or a queen. But this is actually a little more complicated. I could approach this with conditional probabilities, like we did in the last lecture, and I'd have to split it up this way: jack then a red card, or a red card then a jack. But doing this, at some point, I'm going to have to calculate a probability like this one. What's the probability of being dealt a jack given that the first card was red? And this is tricky because it depends. If that first card was a red jack, the answer is different than if it was something other than a red jack. We could make it work. It is possible to do it that way, but it's a little complicated. So I want to introduce another way of approaching this using something called a decision tree. So what I'm going to do here is I'm going to think through all of the possible ways we can be dealt these two cards, focusing on these two things that I care about, whether or not it's a jack and whether or not it's a red card. Okay, so one possibility for the first card is that it's a red jack. Second possibility is that it's a black one. Third possibility is that it's a red card that's not a jack. And the fourth possibility is that it's a black card that's not a jack. So I want you to think these through and just kind of confirm for yourself that these are all of the possible options for being dealt a single card. Okay, so how about the second card? Well, if we're dealt a red jack, all I care about at this point is what the color of the card is. Did we get a black card, a red card, or a black card? Similarly, with the black jack option here, did we get a red card or a black card? Now, for this third branch, for this one, I care about the suit. I care about the rank of the card. Did we get a jack or did we not get a jack? And for the fourth branch, again, I care about whether or not we got a jack versus not a jack. Well, we would need to complete our hand. Okay, so let's focus on just one of these branches. Let's look at this left-hand branch. Right jack, then down to a red card. Okay, so how would I describe these events? Well, the first one here is just being dealt a red jack. That's easy enough. This second branch, this is being dealt a red card given that the first card was a red jack. And this probability down here, right, the final end of the branch, this would be being dealt a red jack and then a red card. Okay, so let's replace these with probabilities. All right, the probability of being dealt a red jack is 2 out of 52. The probability of being dealt a red card, given that the first card was a red jack, normally there's 26 red cards, now it's down to 25. So this is going to be 25 out of 51. And we know what this bottom probability is, right? The probability of a red jack and then a red card, we use our formula. Our conditional probability formula says it's the product of the individual probabilities, which is 2 out of 52 times 25 out of 51. Okay, so let's just put that up here, right, and hold on to it. So what I want to do now is I want to plot out all the paths that give me a success, that give me a jack and then a red card. So this path is 1, and this path is 1, and that's all of them, right? None of the other paths give me what I'm looking for. So let's work out the probabilities for each of these paths, right? So here it's 2 out of 52 to get a blackjack, then 26 out of 51 to get a red card, because there's still 26 red cards at this point. So that probability is 2 out of 52 times 26 out of 51. Okay, so how about the red not jack and then a jack option? Well, the first probability is 24 out of 52. There are 24 red cards that are not jacks. And the probability of a jack, well, all 4 are still in the deck. So that's 4 out of 51. And if we multiply down that branch, we get this product. Okay, now we can answer our question. Right, the probability of a jack and then a red card is the sum of those probabilities. because they're all disjoint, right? Because they're all disjoint, we can just add them up and get the total. And if you think back to our previous lecture, this is the probability of Jack and red, not Jack and then red, because both Jack then red and red then Jack are covered in the branches that we chose to add up, right? So this whole structure here is what we call a decision tree. So in the next lecture, we're going to hit what is one of the highlights of this chapter. We're going to continue with seeing ways that we can use this conditional probability idea to answer questions by developing something called Bayes' theorem.